Hello. This video will demonstrate analysis for the Coursera Course project. The course is Machine Learning Foundations for Product Managers, and the goal of this project is to develop and analyze performance of machine learning model. In this project, we will build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. We have a set of 9,568 hourly average ambient environmental readings from different sensors at the power plant, which we'll use in our model. The features in the data are ambient temperature, ambient pressure, relative humidity, exhaust vacuum, and the target variable net hourly electrical energy output. For this problem, we will be use supervised machine learning type. The reason for that is that because we have both input features and output target, this will allow us to use and train a machine learning model for both input features and output target. We will build two different models, and we will evaluate those models based on various criteria, which I'll describe in a minute. One model will be using all four features, and the second model will use three features: temperature, ambient temperature, relative humidity, and ambient pressure, and we will exclude exhaust vacuum, as in our hypothesis this is a less relevant feature. For our supervised machine learning, we will use a regression model as an algorithm. Also, we will be building this on on AutoML, so we will utilize all the power Google provided us. This model will split the whole data in three parts. Training set will be 80% and validation set will be 10%. Test set will be 10% as well, and AutoML will randomly split the data across these three sets. AutoML calculated all key output metrics for us, and as you can see on the screen, these metrics include mean average error, mean absolute error, then mean absolute percentage error, root mean square error, as well as root mean squared log error. And finally, R squared is calculated for us as well. So as I mentioned, the first model includes all four features: ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. AutoML predicted that ambient temperature has the highest importance, or 61%, while vacuum exhaust is the second most important feature with 23% of importance. The second model includes only three features. As I mentioned, we excluded vacuum exhaust in this model. Our hypothesis was that vacuum exhaust is not an ambient parameter, and it would be less important in predicting our output energy, our target column PE. Before we can decide what would be the most appropriate output parameter for us to use, uh, let's take a look at what is our application. So in our application, we are trying to predict output power for combined cycle power plant. If we can predict output power, we can set up parameters so that we can uh, divide generated power between a gas generator and a steam turbine appropriately. For this reason, if our model makes a small errors, our plant overall will still perform well. However, if we will be significantly off in our prediction, we will set up our plant in a less and significantly less efficient way. For that reason, our output parameter should penalize large errors more. So for that reason, we will be using root mean square error. If we compare two models, we model with all four variables has 4.829 root mean square error, and the model with three variables has smaller root mean square error. So for that reason, our model with three variables, which doesn't include exhaust vacuum, works better and provides better predictions. What's interesting in this exercise is that our r squared for model with three variables is less than r squared for model with four variables. R squared tells us how well features included in the model predicts our target output. So while model with four variables has larger error, it actually has larger r squared. It means it's better predict our output target. However, we shouldn't be distracted with this fact, because exhaust vacuum in the combined cycle power plant is used as a feedback feature to set up our efficiency of the steam turbine. So to measure the efficiency of the steam turbine, vacuum switch measures the pressure of the turbine exhaust. So for that reason, this exhaust vacuum has very high correlation with output power. However, this is more a parameter for how plant operates, and it is less important in our prediction of the target energy we will need to generate tomorrow, for example, or in a week. For that reason, I believe that the model with three variables, which includes ambient temperature, relative humidity, and ambient pressure, will generate better predictions with smaller errors. Thank you for your attention, and this concludes this project.